Hi, my name's Tom Ward. I'm a Senior Product Manager with Waygate Technologies visual inspection business. And today I'd like to talk to you about some technology that we term TrueSight imaging. TrueSight imaging is a blend of high-resolution image capturing and processing functions, precision optics, and a powerful suite of proprietary image transforms. And today I'd like to talk to you about a few of those image transforms. What they can do for inspectors is allow for images to be transformed in a way where it's easier to make a determination if something's gone wrong in the asset. It's a helpful tool, and if you take some time to watch, I think you'll agree. Barrel distortion, caused when using wide-angle tip adapters, can make the outer edges of the blades as you see go by look curved when they're not actually curved. Distortion correction can compensate for this. As you see, as we select distortion correction in the video and turn it on, you'll now see that the blade edges are in their true form, their true shape. So this is just a handy thing to employ just to make sure that you're not seeing curved blades that may look damaged but aren't really curved. So distortion correction is a handy tool to compensate for that. Notice how dark the image is that we're looking at in certain areas. To fix this, we employ a transform called high dynamic range, or HDR. This is a technique that combines multiple images captured with different exposure levels into a single image. This improves the visibility at both the very light and very dark areas in a single viewed image. We have several ways that you can use HDR. You can see here there's the normal image that's taken with the camera, and then there's variable HDR. As you're seeing here, you can manipulate it to the specific brightness level that you would like. Or in a second here, you'll see that we can choose a dark version of this, which we've designed, or a light version of this, which we've designed, just to make it a little bit easier and quicker to get to the image that you like. This is really handy in images where you can't see well enough to improve the accuracy of the inspection, making sure that you're seeing anything that's in the image that is required to be seen. Dark Boost is a live video processing function that digitally brightens darker areas in scenes with bright foreground surfaces or glare, but it does so without overexposing or degrading more uniform scenes. In the video, you can see the bright spot on the right side of the image, so we can't see the blades as well as we'd like to. By employing Dark Boost, you can see we've brightened that area, and now an inspector can make a much better view and assessment of the blades that are rotating by. This technology I'm showing you in air turbine blades, but this could also be used in really any other scene that has a similar situation. Glare in one area in the foreground, but something darker in the background that you'd like to take a look at. Notice the bright spots that you see in these blades as they're moving past. This happens because the camera is trying to adjust the brightness to be able to see what it needs to see based on how far away it is from the camera and the light that it thinks it needs. We can adjust for this in blades that are moving across the scene by changing the brightness or Dark Boost that I've mentioned before, and then hitting the lock feature. You'll see here that we go in, we select brightness, we then hit lock when we get it adjusted where we want it. Again, you can do the same thing with Dark Boost. And now as these blades rotate by, you won't have that brightness, again, that you're looking at here with those features turned off.
Hello, my name is Tom Danvers from Waygate Technologies. I'm going to be just talking you through a short video outlining one of the features that we've released in the Mentor Visual IQ, the MVIQ software release version 3.60. That being the live analytic based around the blade counter. It's a tool that we believe will help inspectors, visual inspectors, working inside gas turbines, conducting standard and routine, as well as non-routine inspections of rotating aerofoils, such that the assignment of numbers and counting of the numbers, and the labeling of the video and the aerofoils passing by the scene is automatically done by the borescope. No need to manually count or mentally count the blade numbers as they pass and establish whether you've completed the inspection or missed some blades or mislabeled some blades. So all of that is taken care of by this feature that we've released in MVIQ. It's included as part of the MVIQ Flame Analyze handset, and is also compatible with both Inspect and Touch models also. Rolling through the video, it's in order to launch the analytic, you flick through to the live analytic page and press the blade counter tile in order to turn it on. Then you're invited to basically go through the steps associated with setting up the analytic, the blade counter analytic. So there's a number of lines that you really need to assign onto the screen. And that's only done once you're happy with the view that you have with the probe, because at this point onwards it's necessary to keep that probe fixed in place. So you've seen me assign the blue and the red lines, that's the entry and exit lines associated with the edge passing through that region of interest. And finally the limit line that contains the trigger point, such that when that line passes through that trigger point, the edge counts up or counts down. Once set up the analytic, it's now necessary to what we call verify the analytic, verify the blade counter. And this requires the rotation of the spool such that a minimum of 3 blades passes through that region of interest. Here you see 3 blades passing through, and the question being, did you count 3 blades? You either answer yes or no. If it didn't count appropriately, then it's necessary to press no, and then you're invited to repeat the sequence. It might be necessary to change the position of the lines, maybe the lighting, maybe the probe needs to be set up in a different position. But most often than not, it will be reliable, it will work, and you'll then, in that case, press the answer, the yes, and then you're presented another 2 further sort of questions. How many blades exist in that current set? Enter, if you know the number of blades, then enter the appropriate number such that when you reach the total amount, it'll then return back to 1 rather than counting up to 999, which is the full count. The second question being, what blade number do you want to start the inspection on? Usually that would be number 1, but yes, if for whatever reason you need to start the inspection perhaps based on a different blade number, because that particular blade that contained perhaps that defect was assigned a different number from a previous inspection, then you have the opportunity to start the inspection using that same blade number. So having pressed done, you're now basically in a position where you can, if you choose to, adjust the position of the blade number sort of text box to a position that perhaps just suits your personal requirement. I like to place it in a position where it's such that the box coincides with the actual aerofoil passing by through the scene. It's entirely up to you where you want to place that box. Now you see me just sort of gently rotating in towards the backward sort of position, just to remind myself how many blades that I did type into that set, and rolling it forward gently. This is the point where you can then, if you so choose, have those lines switched either to the on or off position. At any point in time you can change your mind and make that happen just by pressing that image soft key. And yes, this is an instance where I've found it necessary to do a sequence of blade tip clearance automatic measurements. So in conjunction with the blade counter, it's a very time efficient process upon which you can invite the device to detect the blade tip, and it will detect the shroud and present to you the result of that analysis associated with the minimum, maximum and average blade tip clearance depth measurements associated with that blade. By saving the image, obviously you have the blade number all contained within the file data, as well as all that measurement information, such that you can retrieve and change and interrogate that data on the device or perhaps on the computer using Inspection Manager software at any other time after the inspection. So here we just see how quickly and how reliably it is possible to inspect and obtain such bladed clearance measurement information, in this case associated with each aerofoil. And there's no need to relabel and update the text box. As we've discussed, we can just update, and it updates automatically using the blade counter analytic. So there you have it, blade counter. It takes 60 to 90 seconds to set it up, perform the verification process, and away you go. That's the blade counter, included as part of the version 3.6 operating software update for the Mentor Visual IQ.
Hello, my name is Julia Wilson with Waygate Technologies, and I'd like to speak with you briefly about confined space inspections and the solutions provided by Waygate Technologies to utilize robotics in making these inspections more efficient and accurate. So typically for a confined space inspection, a confined space work permit is required. This involves lockout tagout procedures, establishing a watchman while people go inside, arranging for a rescue crew should they be needed, and constructing a sizable amount of scaffolding inside the asset. By utilizing advanced robotics and the latest NDT technologies, we are able to perform a NDT inspection of a confined space without ever having to step inside the confined space. So today I'd like to walk you through that example. So let me roll the video. And the first step that we'll take here is to look at the asset and build up a digital model of the asset using an asset builder software. This easy to use software removes the requirement for design software and lets you build up the components, as you can see here, based on dimensions of the drawing until you get a complete replica of your asset. Next, we will perform a simulation of the inspection. So you can see here the report can already be generated without any NDT data yet. And you can actually simulate going inside the asset with the bike crawler to show what the path might be of that crawler inside of the asset. You can also mark where you want to take inspections. You can pull up data from the last inspection so that you can reference what you found during the last inspection and ensure that you come back to those points of interest on the next go around. What you see now is the bike actually inside the asset. So the bike is our robotic magnetic crawler that is super maneuverable, can go over obstacles and around corners and collect data. So here you can see the blue diamonds are showing NDT data, and the data that can be collected with the bike includes visual, which you can see examples of here, as well as ultrasonic thickness measurements and structured light. Once the measurements are complete, the bike is exiting the vessel, and you can see that all of this is performed without a person entering the vessel, and thus no confined space entry permit required.